Hello. Now we'll talk about Python exceptions. So what is exceptions? Exceptions are, it's an object, right? So basically it has a class as well. So in Python, all the exceptions inherit from the base exceptions, right? But most of the exceptions that we deal with are inheriting from the exception class. So we have this base exceptions, then we have the exception class, which has all the basic exception implementations, right? So here we'll see that hierarchy, right? But first, when we erase the exceptions, right, it trigger the exception workflow. That means, and first understand how the exceptions are the object or what are the type of the exceptions. So when we check type of the exception, we'll get type as an output. So this means that this is the exception class, right? And here we are getting the object of the exception class. And let's see what is the class for this object and what is the type for this object. Here, when we examine the object of the instance, for both we'll get the output as an exception class, right? And this object is also the this object is also inherit from the base exception class. So when we check whether this object is the instance of base exception, we should get true over here, right? Now other exceptions like the index error, like all the exceptions, right, are inherit from the base exception always, right? So here when we check whether this index error is the object of so index error is a class or lookup error is a subclass of the index error or not, right? Here we're checking whether this lookup error is a subclass of the index error or not. When we check this, we'll get true. So first we have implemented the lookup error. Inside this we have the index error. Now here we can also check whether this lookup error is coming from the exception class or not. Here we'll check that, we'll get true over here, right? So whatever the exceptions that we deal with, right, all the exceptions goes all the way to the base exception class or the exception class, right? Now consider these examples. Here we have this list with the 3 element. When we try to access the 4th element with this code, this would give me the index error, because now we are passing the more this so like here we are getting the index error because this index is not in the range of this list item, and we can handle this error by using try statement, right? So here what we can do is whatever the code we have, we can write in the try statement and handle the exception in the except block. We generally call this as an except clause handler, right? So first we try to run the code. If there is any error, that will be handled by the except block. Here we are saying that except index error will get this. So this is an object, and here we are trying to print the class of the object and even the string representation of the object. So this is the string representation of the object, and this is the class of the object. Let's try to run this. Here we can see that, right? As we can see that we handle the index error exceptions using except block, but we already know that index error inherit from the lookup error. So instead of index error, we can also accept or handle through the lookup error. And when we try to run this, here we are just trying to print the object, like here we're just trying to print the class of the object. Here we'll get the same result, right? So what we have noticed is the exception that is raised is still giving you the index error, but it is handled through the lookup error. So when we handle the exceptions, the handle will catch the exception type, right? Or it can even catch caught by any subclass of it, like this is how we are doing, right? And we can broaden our exceptions to include the exception class, right? So here, instead of using lookup error, we can use the exception class, the main class of the exceptions. Here we are trying to handle the exception with the exception class. Let's try to run this, and still we are getting the index error, right? But there is a problem when handled with the broader exception. This is like we are handling with the broader exceptions. So the problem is sometimes we'll get error because of something different, right? But we'll not get a meaningful output out of that. So the better approach is you should handle the exception using the specific exception only, right? And by the way, this most standard exception also have both str and RAPR custom representation. For example, consider that we have this value error, right? Here we're trying to see the string representation. So we'll get the message which is passed into the class, right, as a string representation, and as in the REPR, we'll see this entire error as in with the name as an REPR representation of it. Now the next we'll talk about the stack trace, right? So here we'll talk about the stack trace. So again, so this stack trace is something like when you get the error, maybe you have done like you have written the nested code and then you have got the error in between, right? So this stack trace will help you to figure it out where the error is, right? For example, consider this nested function calls over here. We have this function 1. Inside this, we are calling function 3. In the function 2, sorry, we have the function 1. Inside this, we are calling function 2. In the function 2, we are calling function 3. In the function 3, we are raising the value error. When we run this, now if I call function 3 directly here, we can see that we have got the error. But let's call the function 1 now. So this has been handled directly, right? Let's call the function 1 now. When we call the function 1, what we are seeing is now we have called the function 1. Inside that, it called the function 2. So here it is giving you the arrow to track it. Then again, in the when it run the function 2, it is running the function 3. When it ran the function 3, we are getting error in the function 3. Or you can also look from the top to bottom, so from bottom to top. That means our error was in the function 3, but it has chained up all the way to function 1, right? And of course, we can handle the exception at any level, right? But when we handle an exceptions, right, it is up to us to decide, right, how to point and what to do with that exception. Whether should we run the next code, or whether should we handle the error or something like that, right? Here now we are trying to handle the exception in function 2. So in the function 2, here we are trying the code. So here we are first trying to run the function 3 output, like, so here we're just trying to run function 3. When we get any value error, it will print this, right? So when we run this function 1, right, what happens? Now we know that here we have printed this error occurred and silencing it. So basically here we have handled the error very efficiently. Now let's go. Now let's see that statement, right? That we had discussed that we should never make a handler too broad. For example, consider this example over here. We have the function of square which take the sequence and the index and try to give you the and try to return of the square of that value. Here we have the function called squares which take the sequence and the maxin. We are taking the loop to the maxin, and then we are yielding all the value of square to all the indexes. So right, by using the square function, what we're trying to do, we are just trying to get the specific value and square it. Let's run this. Now here we have this list with the 3 element, and when we try to run this squares L comma 4, we know that fourth index is not available. So when we try to run this, what happened? Here we have got the index error, right? We have not handled it yet, but let's try to handle the exception with the exception class. So here again the same for loop, we are trying this code. If there is any error in the code, so we are handling that exception, that error through the main exception class, not base, but the main exception class, and then we are returning none after that, right? So let's try to run this. Now when we run the same code again, here we know that we'll get the square of 1, 2, and 3, but at the index of 4th and the 5th there is no value. So this function has broke, and we have got all the output through 149, right? Now this will deal with if there is any bad exception happens, right? Now let's see this example over here. Like over here we have this string, and when we try to square that string, what we'll get? We'll get the type error. That means we cannot take the square of any string value. Now consider these example over here. Here we have this list with the 1, 2, and then 3, 4, where 3 is in the form of string. This is a string data type. And then we have the 4, 5. Now when we try to run the code, right, what will happen? Here we have squared the value of 1, squared the value of 2. But when it came to this 3 element, right, and because this here, we are considering that if there is any index error, then that will be handled. But here, this error is called type error. So here we are at this point, we are getting the error as a type error. But when we run the same code, the square code, right, this functions, right, it has been handled by the exception class. So it has been handled by the main exception class. So that means it can handle the type error as well, it can handle the index error as well, and the other exception as well, right? So it broke the code. We was not expecting that, right? So we can do this in a much cleaner way. Like here, instead of just specifying main exception, we can simply specify handle through the index error. Now when we run this, if I pass this, now this time this exception can only handle the index error. It cannot handle a type error. So if we'll get any type error, then that will be signal that now we are getting a bad input. This is not the error of index, this is the error of bad input. So this is a different type of error, and here we'll get it, right? So now we are aware that what is the problem happening over here. Now again, this bad index error will still work over here. We can see that. So we have to be careful if we are using the broad exceptions, right? And again, for sometimes this kind of broad exceptions can be possible. Like consider that here we are working with a database, right? And like we are writing the data to the database, and the applications will kind of break if any exception happen into the database, or this database should be rolled back if any exception handled, right? In that case, we can use the broader exception or the exception class. In fact, we can even use this even broader exception class. We will not give any name over here. This is called bare exception class. So we'll simply try the code, and then we'll say except here we are handling this exception through the base exception class, and we'll print it, right? So this is the basics of Python exceptions, right? Thank you very much.